All right, let's just review some of the functions we've learned with XSLT. We have the value of, which essentially just selects the value of a node. The for each, which is our looping function. We have choose. It gives us a little bit of conditional functionality. We can sort things. We can sort them alphabetically, A to Z, Z to A, and we can sort them numerically. Starting with 1 or descending from whatever your highest number is. And then we have if, which is again kind of a conditional statement or function that we can use. XPath also has functions. It can do various types of processing. These are functions just like the ones used in general programming languages. But these are built in, so typically anytime we use them, you're going to use some kind of, use them in the context of XSLT. They will not have XSL colon in front of them. If you remember our XSL value of, again, you're going to have to use XSL because it's part of the XSLT namespace. XPath's a little different. Normally you're not going to be using that prefix in front of that. All you have to do is just type it out like what we have here. So let's look at these, and we're going to go over them in the presentation, but we'll just go over them in brief right now. We have count, which is a function built right into XPath, sum, round, format, number. These are all functions that you would use in a spreadsheet application, Perl, PHP, any kind of language that's got any kind of reputation on the street. They're going to have these functions and operators to allow you to do certain types of manipulation to your data. Division, multiplication, addition, and there's a lot more. So let's look at one of them. Here's count. Let's look what it does here. So of these wonders, we're going to do a value of select, and it's essentially going to go in and do what looks almost like an absolute path, but it's going to do an XPath expression here. So let's look at this first. Ancient wonders, wonder, history, how destroyed. And whatever node it's on, so this would probably be in some kind of for each loop, I'm guessing, but whatever node it's on, that node, which is this, or the current node, that's what the dot is there, says, is it equal to earthquake? So whatever that value of that node, it's going to say, is it equal to earthquake? And it's going to, if so, it's going to grab it, and as it's going through these, it's going to count them. So it's counting basically all the ancient wonders that were destroyed by an earthquake. So say we have 20 ancient wonders. I forget how many we have. I think it's more like 7 or 8. But say we have 20 of them, and it counts all 20, but it only finds right here that 4 of them were equal to earthquake. It's going to give back the number 4. So in this case, it would say 4 were destroyed by earthquake. Okay, so we have another one here. Here again we have a value of select. In this case we have a relative path. So it's going to go where it's going to be on that the node that it's on, the context node, and it's going to select all the descendants of that. So here we're going to do how destroyed. Whatever how destroyed is on, it's going to be looping through those. We've got a count, and it's going to take the context node, which is the dot, and say, is that context node, the value of that context node, equal to fire? And presumably, again, this would be in a for each loop. It's going to count through all those, and after the loop is done, every one that it found that was equal to fire, it's basically counting each time, 1, 2, 3, it's going to count those. Once it finishes, whatever that count was, it's going to print that out. So it would say there were 3 of them that were destroyed by fire, it would print that out, 3 were destroyed by fire. And then here you can see how we can do a little bit of math. I've got a minus sign here, so we have a value of select, so it's going to return whatever the value is. We use these all the time. Count, it's going to find all the wonders. So again, we're doing our forward slashes here for our relative path. So it counts all the wonders, all the wonder nodes, because each wonder presumably is a wonder, each wonder node is one wonder, right? So it counts through all those. So again, say we have 8 or 9 of them. Let's go with 9 just for the purposes of this example. And counts them all up, and then it's going to subtract, again, count them all up, how destroyed. And in the context of our the examples we've been using in the book, anytime that it's been destroyed, it will have this element there. If it wasn't destroyed, there is no element used in the XML document. So one of the ones we know that was not destroyed would be like the pyramids. They're still like standing, or say, for example, Great Wall of China. I think that's another one. Anyways, anyone that's got a how destroyed node will get subtracted. So say we have 10 of, there's 9 of them. Say we have 2 of them that are destroyed. It does the math, and it says 7, prints the number 7 is still standing.